Okay, so coming back to uh, ठीक है. This is lecture number 3. Okay, you can while we are learning code writing in C++, once you learn C++, you can go to any language you want because the behind the scenes structure is almost same for each language. Depends on whether you are going for the compiled language or interpreted language, but the basic structure for writing code for the computer is essentially same. You have to declare some variables, you have to store some data coming in from the user or from the sensors. You have to take some decisions and you have to do some things repeated multiple times. I'm referring to loops. Then you have to perform the, actions based on whatever the data is coming in and take the decisions that's there. The behind the scenes structure or logical structure remains the same, only the syntax changed somewhat. So you can use code writing skill to write programs for your computer. I'm talking about Windows, or if you want to write Windows application for your Windows platform, you have to use Microsoft Visual C++ or Visual Basic. Once again, it has pretty much the same structure as C++. Or you can use, if you want to use write programs for iOS or Apple system, you have to use Swift language, sorry, not C sharp, Swift language. C sharp is not for Microsoft Windows. If you're going for Android app development or iOS development, once again, you have to go to Android IDE, Integrated Development Environment for Android. And you can use the very same C++ coding concepts to program Arduino, Raspberry Pi, or ESP32, which is very famous in our NED, or ESP8266 microcontrollers, etc. And as well as other embedded systems such as 8251, really old embedded system. You can use your C++ programming skill to program these systems as well. If you want to learn more about Arduino Raspberry Pi, I would suggest you go to, we probably would be covering a few things about that in our course, but not the whole thing, obviously, because this is about C++ specifically. We are going to write the command line programs here. But you want to learn Arduino Raspberry Pi, I would suggest you go to coursera.org. Let me show you. If I go to this coursera.org, you will, and there's another website, something known as edx.org. So let me open that for you. If you go to, let's write our, so you will get over here, you will get the Introduction to Programming and the Internet of Things course, which is and building Arduino robots and devices, Arduino platform, and C programming. Once again, C programming and C++ programming. Whatever there is in C programming, it's all there in C++. So once you learn C++, essentially you have pretty much learned C as well, because C is now a subset of C++. Interfacing with Arduino, then so on and so forth. You can do one of these courses. You can just pick the beginner level or mixed level. There might be few series of courses. You do not need to pay any fees for that. They are essentially free courses. But if you have some time available, maybe 3 to 4 hours per week, you can do these courses in your free time. But you need to have some Arduino board with you, and you have, or if you are going for Raspberry Pi over here, so Raspberry Pi, if you go here, it has more memory, about 1 or 2 gigabytes of RAM. So Raspberry Pi platform and Python programming for Raspberry Pi. This is a very good course over here. And essentially, if you're going for Internet of Things, where each and every appliance or small items or small sensors are connected to internet and they are working together to perform some specific task, you can use that Internet of Things platform to have something known as a distributed intelligence, where you have a small devices taking decisions themselves, running their own codes and working together to attain some specific task or working towards some goal. So if you can afford 2 or 3 hours per week, I would suggest you go to this website. And there is also another website, edx.org. You can search for the same course, Arduino Raspberry Pi. Really useful for your embedded systems, because in NED, I think you will be learning these embedded systems maybe in your third year and maybe in your final year. So actually, the problem is, and this is important, the problem is that once you are in third year or once you are in final year and you are learning these courses, because if you are doing some hardware based projects, if you are doing some automation based projects, you have to learn these courses. Problem is that in your you get to decide your final year project in your third year, and you start working on your final year project in maybe in your fourth year. And the fourth year is actually not of 12 months, it's actually of maybe 9 or 10 months. So if you spend like 2 to 3 months or maybe 4 months learning the actual course or learning the actual hardware, you will not have much time to implement whatever you have learned in your hardware project, because hardware projects require lots of tries, and usually they fail in about 5 or 10 tries in the beginning. But once you get a feel of it, and once you get the how they actually work, and once you learn to troubleshoot those hardware based courses, now then the things becomes quite easy. But the point is that starting like 100 hours of that course or the starting 100 hours of practice actually quite difficult and actually quite frustrating. But once you learn that skill, that actually helps you a lot. So what I'm emphasizing here is that if you want to do this automation or these hardware based uh, projects in maybe in your professional life as well as in your final year project, you have to learn the courses right now. Reason is that you learn these things in your first year, you practice in your second year, and third year you will have a very good idea of what project to pursue and what field to pursue. But if you learn these courses in your third year or final year, which many of our EE electrical students actually do, unfortunately, they simply do not have much time to they simply do not have much time to actually implement that. I mean, they actually remain in the beginner stage, or they actually remain in the learning stage. I mean, they spend so much time actually learning the stuff, they simply do not have much time to actually implement the stuff, if you know what I mean over there. So I mean, this thing is important to learn, and I would suggest that if you can afford 2 or 3 hours per week, which is actually available, even though you have a lot of load for your recorded classes as well as the live lectures, but if you can afford like 2 or 3 hours only on the weekend, it's actually not that difficult to do this course. I mean, actually, if you have some problems in following any of these things, I mean, I and Sir Iqbal Azim and Sir Hassan and Sir, I think Feda, I mean, they are quite expert. I mean, they can help you out in actually if you start stuck somewhere, or I mean, and this Raspberry Pi and Internet of Things has a very good Stack Overflow um, pla- uh, forum in which you can post your questions and see the answers which others have posted. So coming back to that, code writing is a very useful skill. You need to learn these things if you are going to program a few things over there. And how to practice writing code. I mean, the problem is that since we do not have the practice to type without looking at the keyboard, that becomes quite frustrating, because our code writing requires writing some brackets or curly brackets or square brackets or greater than sign or less than sign and semicolons, and I mean lots of things, lots of weird looking characters we need to write on the computer. The problem is that we usually are hunt and peck type. By hunt and peck means that we actually need to see where each key is and then press that, so that, I mean, you simply cannot write faster enough, and it becomes quite frustrating to look for the each key and where each key is, and then pressing that button and see whether that we have typed it correctly or not. So what I suggest is that you spend some time, so a few minutes, or maybe I don't know how many minutes you require for some learning touch typing. I mean, there are lots of typing tutors or typing tutor programs available on the internet. You just go on the website, start typing, and they will teach you how to touch type. By touch typing, I mean that you do not need to look at the keyboard while typing. I mean, that's pretty much the only way to write the code fast enough. And if you're looking at the keyboard, that means you're obviously not looking at the screen what you're writing. So the best way to write the code is by never looking at the keyboard. You have to remember where each key is and how to press that key with the appropriate finger. I mean the hand positioning and the finger positioning is actually taught on these typing courses available freely on the internet. So I would suggest that you dedicate some time writing code on a computer, maybe half an hour to 1 hour per day, or maybe more. The more the better. And one of the students actually said that where are the exercises. For exercises, I would suggest that you go to let me where is that for exercises, I would suggest you um, go to the textbook which I posted on the class forum. It's available. I mean, detail C++ how to program. I mean, that's how it looks like. Sorry, I mean, that's how it looks like, the screen, I mean, on the top page. If you go to exercises, I mean, some of these exercises are essentially filling the blanks and MCQs, and some of them are essentially case studies, but not much of them. I mean, you can do chapter 2 exercises based on what we know right now. So you can do chapter 2 exercises just for C out and C in, and some simple mathematical calculations. And as we go along, I would be saying that do this chapter exercise or do that chapter exercise, end of chapter exercise. What I mean by that, if you see something which is not discussed in our recorded lecture, you can see the text of uh, that chapter. So I mean, we have discussed chapter 1 and 2 quite extensively. So coming back to this thing, do end of chapter exercises, little textbook, chapter 1 and 2 for your practice. Okay, so coming back to lecture number 7. From lecture number 7, I said in the very beginning, I said that we cannot change or override the value of constant. That means that if you're declared some variable constant, you cannot override the value, or you cannot have any other process override the value of that constant. That will throw up an exception that constant cannot be overwritten. The number part 2 was, I think some student asked, I think who was that? Okay, it's asked that what is the difference between this thing or that thing, or the typecasting. By typecasting, we mean that if I have a number which is C, okay, I mean, C can have a character, C can have any number or any expression which evaluates to a number, such as 5 plus 2 or 7.9 plus 2 plus 3. So if I write integer in round brackets and I have C right next to it, that will converts the whole the return thing, or the whole result of this expression would be an integer. If I write this integer and in brackets, which I write the value or some number, and I want to convert that into integer, this is typecasting actually, and this expression also has the same result. The integer and bracket, you write C over there, or if you write integer within brackets and then write C, I mean, this thing and this thing has the same result. But there is a difference behind the scene, what is actually happening here. Integer C, let me launch a program for you. So if I make a new file, so if I'm just writing the code. If I write character C equals to U, and that's it. And if I make this thing, if I have integer A equals to integer C, so what actually happens over here, or if I write, I'm not writing this code, I'm just saying, or if I do this, integer B equals to integer C. Okay, so what actually happens there is, I mean, the result of both of these statement would be same. I mean, C would be converted to integer, and that would be assigned the value, but that would be assigned to A, or C would be converted to integer, and that would be assigned to B. That means, I mean, behind the scenes, the process is actually slightly different. Is that here we are making a project, sorry, we are making an object of type integer, and we are initiating or initializing that the value of that integer object with the value of C, whatever the value of C is in integer. And then since the here in this expression, the return of this expression, I mean, if you just replace this thing, or what's the value which is returned over here, that would be an integer, and that integer is assigned to A. So essentially this is actually making an integer type object which is initialized to value C. Here what we are doing, we are converting the value of C to integer. This is actual typecasting. We are converting the value of c to integer, and we are assigning that integer to b. I mean, the result of both of these expression is essentially the same. So I mean, if you want to this use this or use this for typecasting, both are okay as far as our course is concerned. Okay, so coming to the next thing, Ascii table, I've discussed that quite in detail, so no need to do that. I mean, we will be primarily dealing with Ascii values because we will be writing code in English, and we will be dealing with English letters. If you want to write your language other than English, or if you want to um, manipulate letters other than English, then you have to use something known as Unicode. Obviously, ASCII is essentially 8 bits, sorry. So it goes from all the way to 0 to 255. So not many characters can be supported over there. I mean, like Urdu has more than 26 characters, right? So and other languages have even more than that. So for all languages, Unicode is used, and you can see this website home.unicode.org. I mean, coming to here, if you go to Unicode character and home.unicode.org, and it has a technical frequently asked questions which you can see over there. And they, I mean, obviously it has maybe a 4 byte or maybe, and it depends on what language we are using. It might go all the way to 8 bytes as well. So it has like thousands of possible characters over there for pretty much all the languages in the world. But the important thing is that your operating system must have that language pack installed so that it can display the that appropriate character, because in behind the scene, each of these characters is also a number, and that number, that Unicode number, or that 4 byte or maybe an 8 byte number, depends on what language we are using. That number is displayed as a special character if you have that language pack installed, but that language pack actually enables the computer to display that number as some kind of a script or some kind of a drawing which we perceive as character. So we'd be dealing with ASCII codes, but if you want to do with other languages, you have to use something known as Unicode. If you want to do Urdu or maybe any other language we want to. Okay, so coming to next slide, everything in a computer is a number, which I have emphasized enough. Files, images, sounds, images, everything. Even the programs we are writing in C++, they are also they are also number streams. The reason why we compile that code, is converted to ones and zeros so that computer can understand, and that code contains the variables, and that code contains the operational instructions for computer to perform. And they have I mean, essentially all of them are numbers. So for numbers, we discussed the number system: decimal, binary, hexadecimal, and octal number. The most used number systems are essentially decimal and hexadecimal, because hexadecimal is just a short way to represent the binary numbers. Reason is that octal numbers are not that used anymore. They were once used, I mean, in a long time ago, but not much really. But behind the scene, everything in computers is binary, and the easier way to represent binary numbers is hexadecimal, because each hexadecimal number, which goes from 0 to f, or 15 in decimal, I mean, they have 16 numbers, right? So each hexadecimal number can be represented in a 4-bit binary number. So it's actually easier to understand over there. Decimal numbers for our understanding, but computers do not use decimal behind the scene. They use binary. And as you will see in lecture, um, I think 15 or 16 maybe, that even if you are representing like 0.2 in decimal, which seems like a normal fraction, 2 over 10, computer simply cannot represent 0.2 accurately, because that will be a rational never-ending fraction in binary numbers. So you will see how that works. So there are some problems in binary numbers, but computers are stuck with binary because they have transistors built in there, and they can have 1 and 0, only two states to save to save the number. Okay, one thing which I did not cover in the actual lecture was how many bits for a number. For example, we want to represent 129 in binary. How many bits are required? So the easiest way to do that is, we know that the number of bits required to represent, or if you have an 8-bit number, if we have a 8-bit number, the maximum number we can represent in those 8 bits is 2 to the power 8 minus 1. So we have 2 to the power 8 is 256 minus 1 equals to 255. That means if you have an 8-bit number, so the maximum number I can represent is 1111, 1111 or FF in hexadecimal, or 255. I mean, this F represents this 15. I mean, this F represents this 4-bit number over here in hexadecimal. So actually it's much simple to represent the binary in hexadecimal. So we say that 2 to the power 8 represents, it can have 0 to the range of 2 to 8-bit number will go from 0 to 255, or we still have 256 numbers. We do minus 1 because we are counting from 0 to all ones. All zeros to all ones. We are counting from 0 to 255. We still have 256 possible combinations over here. So the original question was that we want to represent 129 in binary. How many bits are required? One way to do that is to guess the number, or we can say, okay, we have 2 bits, we can represent 4. For 4 bits, we can represent all the way to 15. Sorry, in 2 bits, we can represent 3 over there. In 8 bits, we can represent 255, and 9 bits, we can represent 511, maximum number. So what we can do is that we can take whatever number we want to store, and we want to figure out how many bits are required to store that number. We have to take log to the base 2 of that number. So if we have 129, so log to the base 2 of 129, let me get the calculator over here. Okay, so where is log to the base 2? Actually, it simply does not have the log to the base 2. Okay, so I'll just take 129 log to the base 10 divided by log of 2. So that's actually same as log to the base 2. So I get something like equals to 7.011 over here. So that means always round up. That means that you need not 7 bits, you need 8 bits. You need 8 bits to represent 129 in binary. Let's take another example. Let's say I want to represent 1029 in binary. How many bits are required? So obviously 10 bits is, I think, 1024. So let's take the 1029 log divided by log of 2. Actually, I do not have the facility to take log 2 of that 1029. So I'm taking log to the base 10 of this number divided by log to the base 10 of 2, which is essentially same as taking the log to the base 2 of 1029. You can do the log to the base 2 in your calculator. So we get 10.007. So log to the base 2 of 1029 is 10.00 some number. So it was not exactly 10. So obviously I need at least 11 bits to store 1029 in an unsigned binary number. Had it been a signed binary number, the story would have been slightly different. But always, I mean, if you are not so sure about it, if you're going for signed or unsigned, if you're going for signed, the easiest way to do it is, I mean, instead of 11, take 12 bit to just to be on the safe side, and leave 1 bit for the signed bit. I'm going to discuss that in I think in lecture number 10, 11, 12, some of those lectures actually. So that is just take base log to the base 2 to find out the number of bits to represent that number. If you get a number which is in fractional form, always round up to the next number so that you have the number of bits over there. The last thing I want to discuss is decimal to binary conversion. I discussed the direct method. There is another method, which is the divide by 2 method. Divide by 2 method is actually discussed probably in your book. You need to check out your book, in which you have to repeatedly divide a number by 2 and figure out the remainder. That means that, for example, if I have a number, let's say I have a number, just pick any number. Go over there, make a new file, and delete this thing. Okay, I have a number. For example, I have 294, and I want to convert this 294 to base 2. I want to. I mean, the one way to do it is I've explained that in the recorded lectures was 1, 2, 4, 8, 16, 32, 64, 128, 256. So you turn on 256, and then you turn on I mean, whatever the remains from 294. Let's do it quickly. 294 minus 256. So you have 38 remaining. So I turn on 32. So 32 is turned on. I mean, only 6 remains. So just turn on 4 and 2, and that's it. So you just leave all the bits 0. You only need turn on the bits which are required. I mean, you first turn on the bit which is the largest or equal to this thing, and then you turn on the bit which is largest or equal to the difference which we had there. So 256 minus 294 minus 256 was 38. We need to turn on 38. I cannot turn on 64 and so on and so forth. I turn on 32, so only 8 remains. So only 6 remains. So I just turn on 4 and 2, and that's it. Now, what I can do is, there's another method which is discussed probably in your book, which I just take the remainder and I just divide it by 2. So if I divide it by 2, so I need to have 147, and the remainder here is 0. Then I again divide 147 by 2, so I have 73. Remainder here is 1. Then I divide 73 by 2. 236 is 72. Remainder remains 1. I mean, this is the remainder line. And divided by this to 18, the remainder is 0. Then I 2 into 9 is 18, remainder is 0. Then I divide 9 by 2, so 2 4 the 8, remainder is 1. And then 2 to the 4, remainder is 0. And then I have 2 into 1 is, sorry, 2 into 1 is 2, remainder is 0. And then I divide again, 2 into 0 is 0, remainder is 6, and then I stop. Okay, so I mean, once you have 1 over there, divide again, 2 into 0 is 0, and remainder is still remains 1. This is our most significant bit, and you go all the way over on the top. If I can fit over here, yeah. So this thing over here is the least significant bit. So I can just write in this fashion. So I'm going to write this one over here, 1 0 0 1 0 0 1 0 0 1 0 0 is done. Then I write 1 0 0. Then I write 1 1 0. I mean, that's pretty much the number which we got over here, that 1 0 0 1 0 0 and 1 1 0, which we got over here. So that was the divide by 2 method. It depends on whether, I mean, whether it comes in exam or not. That's not that important right now. You can convert these numbers from binary to decimal from your calculator. So we haven't yet decided, because that whether the calculators would be allowed in your exam or not. If these problems come, obviously the calculators will not be allowed, obviously, because you have to do it by hand, or the scientific calculators might not be allowed, because we need to see whether everyone understands the decimal to binary conversion. So but the point is that you cannot convert the fractional numbers from your calculator in from binary to decimal or decimal to binary. You cannot convert, like if you want to convert 0.3 or 0.4 to binary, you cannot do that in your calculators. Calculator simply does not have that facility unless you have a specific model, which I mean, I think that's a programmable calculator model, which is not allowed anyway. So here, if you want to convert, I mean, the normal, I have FX9N1 calculator. It simply does not have the feature to convert the fractional numbers. It can convert whole numbers, and that's also within a very specific range. So that concludes our lecture. So if anybody has any questions. ये क्या कह रहे हैं सर, ये एग्जांपल समझ नहीं आई सर, यार फ्लास यार इतना स्लो तो बोलना, क्या हो गया? ओके सर, record live lesson, यार I wasn't seeing. Okay, is it necessary to use integer with brackets? Rauf Arshad, is it necessary to use integer with brackets if you are only converting the type? That's it. If you are not converting the type and the right side of the expression is already an integer, no need to convert that. The example समझ नहीं आई. This example is also given. I mean, this example, divide by 2 method, you actually repeatedly divide the number you want to convert. You actually repeat the number. You actually divide the number you want to convert by 2, and just write the remainder on the right. So if I divide 294 By 2, I have 147. So I mean, 2 into 147 is, I think, 294. The remainder would be 0. Then I divide 147 by 2. I have to multiply it by 73. That would be 146. The remainder would be 1. So I'm just writing the remainders in this column, and I just write the remainders from down to up fashion. And and where I have 1 over there, and I just divided by, I mean, 1 divided by 2, the remainder would still remain 1. So I mean, just keep on dividing these numbers, and you end up over here where you have 2 into 0 is 0, and the remainder remains 1. And then you write these numbers, the remainders, indeed from the bottom up fashion, because that thing is the most significant bit. This thing is the most significant bit, and this is the least significant bit. So such as, let's say if I write a number 1120, that is the most significant number, and this is the least significant number, because 1000 obviously much more than the least significant number, which is 0. Acha, sir, explain more integer a. Power, if you can do conversion from, I mean, the power 8 method, that is okay. I mean, I have done this example because I think it's probably given in your book. I mean, could not search it, but I thought it was in your book. You have to, I mean, divide by 2 method is actually the first method which is taught whenever you are converting from decimal to binary. If you're not happy with this method, which is essentially just keep on dividing by 2 and write the remainders. That's it. Keep on dividing by 2. I mean, just whatever the result is, divide by 2 again and again, and write the remainders. If you're not happy with this example, you can still work with this powers of 2 example. I mean, just turn on the bits which are required and leave the rest of the bits 0. That is okay. Hexadecimal number to binary number. If to convert from hexadecimal to binary, you just say I have a number, just write a number AB12. Write 4 bits. I mean, 1, 2, I mean, write for each hexadecimal number, you have to write 4 bits. And here, you have to write 4 bits over here. So 2 is 0010, 1 is 0001, and B is 1011 probably. 1011, and A is, I think, 10. So 1010, sorry about here. So if I write it in a continuous fashion, I will have, sorry for lack of space, AB12 would be 1010, 1011, 0001, and 0010. Instead of, I mean, if you want to convert binary, sorry, hexadecimal to decimal, if you want to, which I did not discuss in the class or in the recorded lecture, is, I mean, you take the same method. I mean, A is essentially 10 into 16 to the power 0, 1, 2, 3, 16 to the power 3. B is 11 into 16 to the power 2 plus 1 into 16 to the power 1 plus 2 into 16 to the power 0, and you have a decimal equivalent number, and then you might want to convert into binary. But I would suggest, instead of going this long way, you can convert directly by just writing 4-bit number for each hexadecimal number you see in the appropriate order. I mean, you just write the number for a 4-bit number for A, which is 1010 first, then you write the 4-bit number for B, which is 1011, then you write 0001 and 0010 for 1 and 2 respectively, and then write them as total again, I mean, collectively, so that you have a 16-bit number over here. अच्छा सर आप मोबाइल एप्लीकेशन बनाना सिखाएंगे? No, we are only going to learn how simple command line based applications work, and we are here to learn the programming concepts. If you want to learn the Android app development, or if you want to learn the Raspberry Pi or Arduino or any other microcontroller based development, you have to see the Coursera course. I mean, essentially these days, because already so much time has been lost in this year. You have probably about 2 or 3 months where simply the university was off. So I mean, I wish I could have told you earlier, but I simply did not have any way to communicate with you. But you need to learn these courses right now. I mean, we are only here to learn the programming concepts, and the same programming concepts of storing the variables, manipulating those variables, taking the decisions, and running things again and again, and storing them in certain special data structures such as arrays and maybe classes and objects. We are only going to learn that. I mean, the same programming concepts, the basis, I mean, the basics would remain the same, but this very same concepts would be applied to any programming environment in which you are working. Okay, so if you want to bring out some names, this should be use character string, or like I want to bring hello Taha Abdullah, please explain this, or possible to write program only main function. You have to write main function. I mean the main function does the main job. So Mudassir Mahmood, can we use any method to which yes, you can use any method. Sir, MITS का syllabus कहाँ तक होगा? MITS का syllabus would be from these variables, declarations, and the number convergence, and it will go all the way to decisions and first loop topic. I will be discussing the mid syllabus in the next class after I am um, done recording with lecture number 24, so that I can see where I can easily cover, because the duration of the lectures has now been reduced from 40 to 30 minutes. So I need to, I mean, obviously the course would be less as as was planned before, but it will probably go to loops. I mean, the next topic would be, I mean, the number conversion and the floating point numbers would continue in the next few lectures. Then it will be decisions, the logical operators, and then it will be loops. In the loops in which we'll be doing few things again and again. If you want to run the code again and again, I think the mid syllabus would go all the way to loops. Okay, don't go anywhere, bhai. I need to take the attendance, so stay with me in a moment. 9:41 हुए बाबा, अभी तो नहीं जाओ. अच्छा, in a moment, just a moment, so that you can sign off. No, not right now. अभी नहीं जाना. Just take the 10. I need to take the attendance. Make sure the attendance is triple 111 students. 110 students. Somebody left here. Okay, attendance has been taken. I'll see you inshallah next week. Allah Hafiz. No, no need to write present, present, present again and again. There is a software behind the scene which marks you present. Just everyone just sign off.